Ladies and gentlemen, it's our great pleasure to present in front of you our work entitled Automatic Human Resource Ontology Generation from the Data of an e-recruitment platform. Our presentation is organized as follows. We begin by an introduction. Then we move to presenting some related works. After that, we will explain our generation process. Finally, we conclude by presenting our contribution and perspectives. So, recent development of web technologies has transformed the world by offering permanent accessibility and high availability of data at the same time. However, existing knowledge representation tools have shown their limits to fit with this revolution. In fact, ontologies can provide better knowledge representation. In this context, using ontologies in human resource domain can be useful for both recruiters and candidates. So, given that human resource domain is characterized by a huge quantity of concepts, how we can generate an HR ontology automatically, then validate the generated ontology. To answer these questions, we have fixed the following objectives. First, generate a human resource ontology automatically, then validate this ontology, and also suggest some use cases of the ontology in the real world. Before explaining how we have generated our ontology, we must introduce some related works. Different researches have been done in order to create human resource ontologies. We begin by the most popular one, ESCO, which is a human resource ontology created manually by the European Commission in order to provide a common European repository to be used in recruitment. This ontology is characterized by three concepts: occupation, skills, and qualifications. It includes more than 2,000 occupations, 13,000 skills, and more than 9,000 qualifications, available in 26 different languages. This ontology is used as a common referential between job seekers and recruiters. There is also Agora ontology, which is a human resource ontology generated semi-automatically using job offers collected from the internet. This ontology is characterized by three concepts: universe, occupations, and skills. It is represented in RDF format, and for its evaluation, their authors have done a manual evaluation by domain experts. Finally, there is HOLA ontology, which is a human resource ontology generated automatically from the professional social network data LinkedIn. It contains two concepts, occupations and skills. For the generation of this ontology, the authors have used community detections, and at the end they got an ontology that includes more than 19,000 of nodes and 100,000 of edges. Now, it's time to present our generation process. Our ontology is called Ahroga, referring to the Algerian human resource ontology generation automatically. It is an HR ontology generated from the data profiles of employatique.com which is an Algerian e-recruitment platform. This ontology considers 4 concepts: professional domains, occupations, communities, and skills. The main purpose of generating this ontology is to improve e-recruitment services of employatique.com. This process is described in the following pipeline. The first step is to extract data from the database of Employatique. Then, cleaning and analyzing these data in order to generate an ontology. And finally, we finish by validating and evaluating this ontology. So, the extraction step. This step aims to extract necessary data and clean it. Our data corpus contains 300,000 of profiles extracted in JSON format. We identify for each profile 3 essential concepts: skills, professional domains, and occupations. In order to clean this data, we have used NLP techniques. Analysis. The purpose of analyzing step is to extract semantic and syntactic relationships. This step helps to create relations between occupations based on their syntax similarity by using Jar-Winkler metric. Then we create an initial graph structure where every professional domain have set of occupations and every occupation have set of skills. Finally, we have performed a community detection on this graph using 2 different algorithms, Louvain and label propagation algorithm, in order to create subdomains or communities. Then we have selected Louvain algorithm because it allows better performance and generates fewer communities. To enable exploitation of our ontology, we transformed the resulting graph in the OWL language throughout the creation of the ontological components, such as axioms, classes, instances, and relations. After generating the ontology, it's time to validate every concept. For the validation of occupations, we keep only those having an occurrence frequency greater than 1%. Using this threshold, we have validated 15% of profiles. For the validation of skills, we have used a machine learning classifier in order to classify skills into 2 classes, valid or not, using naive Bayes classifier, which gave us better precision than logistic regression and neural networks models. We have also done some manual validation by sharing a survey with domain experts in order to validate concepts of 3 different domains: IT, architecture, and telecommunication. At the end, our ontology includes 27 professional domains, more than 700 communities, more than 1,000 occupations, more than 110 relationships, 110,000 relationships, and more than 11,000 skills. Our main contribution, we can see our main contribution in the generation of the ontology in using both NLP and machine learning techniques in order to clean and validate data. And we also used the manual validation by domain experts. As perspectives, we want to consider two other languages, French and Arabic. We want also to consider new concepts like experiences, education level, and we want to use the ontology in the automatic extraction of information from PDF resumes. Thank you for your attention. And there is the references.